The basic idea of a capability study with interval or ratio data is fairly simple, and that's this. We can have a process behavior chart or the histogram of the data in the process behavior chart, and that represents the voice of the process. That's these blue bars here and the red curve that's drawn as an approximation to them. We then compare that with the voice of the customer. Well, what's the voice of the customer? Usually that comes out in spec limits. And the basic idea is fairly simple. If we know the spec limits, and if we know the mean and standard deviation of our process, then we can tell how much of the process is going to be out here in the tails beyond the spec limits. Now, this particular diagram is set up with the spec limits at plus 2 sigma and minus 2 sigma. So we know that we're going to have 2.5% of our instances out in this tail and another 2.5% out here. So we're going to pass about 95% of our goods and fail the other 5%. So let's go to the simulator and see what we can find in the way of data. This simulator has an output variable, which we see down here, in this case 363, and we have a set of input variables to the process that we think might be driving it. Well, you can go in and modify this table and set yourself up a designed experiment and determine how much each of these drives the output, and that's a little beyond what we're going to do here. I'm just going to collect a set of output data and we're going to analyze that. And all I have to do is just start this, and then I'm going to copy this column over into QuikSigma so we can analyze it. So I've opened capability under baseline, and of course I could do the same thing under the toolbox if I wanted. It's available there. I've pasted my output variable here. My default is I and MR, which is appropriate. I've checked my 4 Western Electric rules, and I probably should have pointed out to you in the simulator that our upper spec is 1085 and our lower spec is 565. So now all I need to do is click Calculate. And this is a very familiar result. We've already done behavior charts, so here's my individual, here's my moving range. Again, I've got my histogram here, but what's been added is the specification limits, 565 and 1085. Well, we can just look at that and say, gee, wouldn't it be nice if we could just move that up to center it a little bit? And we also can just look at that and say, gee, it's a little too fat to fit nicely between the spec limits. We've got a problem. Well, we really don't have time in this session to go into PPK, CPK, PP, and CP. Those are quality indices that an expert can use to derive information about the strategy for fixing the process. That's just interpreted for you over here, so it's really easy. It says that we're making 694 and some odd thousand defective parts per million, and if I remove the special cause, it's not going to change very much. As a matter of fact, the difference between those is just due to statistical error. Okay, well, why is that? Well, if we look at this, there is no special cause. This is a stable and predictable process. So removing special cause isn't going to do anything for us. Now, what it says is that if we center, we can get down to about 29,500 and some odd defective parts per million, which still isn't very good. And that if we do both, theoretically, we can get down to this level, which is really just not statistically different from that. So what we find out is that we need to adjust something to move us to the center, But even that isn't going to solve the whole problem. We're probably going to end up redesigning this process to also make it skinnier. So my work is laid out for me.